Welcome back. Up to this point in our section on audio, we've been talking about sound and how it works. In this tutorial, we're going to talk about how your computer turns sound into computer language, that is, the binary code of zeros and ones, and then transmits it back to your monitors so you can hear it as sound. Having a basic understanding of digital audio concepts is fundamental to the digital audio engineer. I guarantee that the more you understand about how stuff you hear interacts with the computer universe, the better your work is going to be. You'll have much more control over the input quality as well as the output while mixing and mastering. We'll begin with a recap of the energy and electronics involved. First, you need a sound, something that disturbs the air and generates sound waves. Next, you need a transducer to convert this acoustical energy into an electrical signal, a microphone, for example. Lastly, somehow you need to store these voltage variations produced by the transducer so that you can reproduce them afterward. With analog recording, that's traditional tape recorders, an electromagnet realigns magnetic particles on the surface of a moving tape, varying the intensity of its magnetic field in response to variations in the incoming voltage. That's how the electronic version of the sound waves gets stored. The magnetic stuff stored on the tape is converted back to voltages through the amp and the speakers. The result is fairly analogous or similar, hence the name analog, to the original signal. It's pretty complex. A real-time chain of physical components directly converts energy from mechanical or acoustic form to electrical to magnetic form and then back again to acoustic. In fact, analog recording has been around for a long time, more than 100 years. Edison found a way to record sound on wax cylinders. Now, if you take a microscope to the grooves, you'd see that they look like sound wave diagrams, with repeating patterns that represent the frequency components of the recorded sound. Same way with a vinyl LP. If you zoom in with your microscope between the grooves, you'd see the shape of sound waves. So that's analog recording. Digital audio recording works completely differently. Digital audio is not sound, nor is it analogous to sound. Digital audio is computer data that represents audio waves. That's what's meant by digital, where something you hear in the real world is converted into numerical form, binary digits, zeros and ones. How does this happen? Well, it does this by analyzing or sampling the position of the wave many thousands of times per second, and then assigning a number to the wave's position at each sample point. It's not a perfect replication because a sound wave is continuous with an indefinite number of points. The digital version is limited by how many samples were taken per second, as well as the resolution of each sample. Resolution refers to how many numbers were used to define the position of the wave at that point. The more numbers, the longer the number, the higher the resolution, and the more precise the digital version will be. We're going to talk more about sample rate and bit depths in our next two tutorials, but you can see where I'm going with this. As you may be aware, there's an endless debate about which is better, digital or analog recording. Some people prefer analog systems for their warm sound and gentle, more natural compression of volume peaks. Since digital audio tends to color the sound less, analog enthusiasts sometimes describe it as cold or clinical. Analog systems are more forgiving at the maximum end of the dynamic range. Analog tape will gently compress a recording's loudest moments. Digital recording isn't forgiving this way, since it uses numbers to describe a sound at any given moment. Once it hits the top of the range, there's nowhere to go. When this happens, you get something called a clip. It's basically distortion like a little buzz, and it's pretty uncomfortable to listen to. For the most part, there's no way to fix it, and your take becomes unusable. We'll be talking more about this topic later in this section. To avoid digital clipping, you want to make sure that you set your input levels based upon the loudest part of your recording. Your software is going to help you monitor for digital clipping. Generally, there's a warning light of some kind that lights up. It's usually called going into the red. Your computer's sound card or audio interface is what manages the conversion from audio to digital and back to audio so that you can listen to it. Once the sound waves have been converted into data, your computer has to work hard to convert it back to sound so you're able to listen to it through your output monitors. That's one of the reasons why working with audio and video is so processor intensive for your computer. That's also the reason that applying real-time effects like reverb, which change the file while it plays, take a lot of computer resources. Later on in this course, and in my other courses on Cubase and Pro Tools, I talk about how to minimize the load on your computer. This concludes our introduction to digital audio.